Okay, good morning. This is Professor David J. De Los Reyes. Okay, my topic for this session will be a very interesting one. This will now be the study of the connections of a three-phase transformer. Oh, we are done with single-phase transformer. Single-phase transformers are actually used on the so-called secondary distribution lines. For three-phase transformers, it's a different one. Excuse me. Excuse me. Excuse me. The application for three-phase transformers is different from the single-phase. For three-phase transformers, they are actually used, okay, on the so-called vicinity of transmission lines and primary distribution lines. Okay, because the voltages at those locations are actually high. Okay, let's proceed. The lesson for this morning will be AC machines, lesson number 34, and this will now be the study of three-phase transformers. Three-phase transformers are actually just three single-phase transformers which are unconnected, okay, to form the correct connection. If it's Y, you know how to connect Y, right? It's a letter Y. It's a letter Y. So there will be three windings in each phase. So to make a three-phase, okay, there should be a common point. One line goes out, another line goes out, okay, and another line goes out. So they should be H1 maybe, H2, and this is H3. So to produce a three-phase, there should be three single-phase transformers which are unconnected to make it just a three-phase. Oh, that's the first alternative. But the second alternative is to require economy on the so-called production of three-phase transformers. We will not be interconnecting single phase. We will just make a three-phase transformer as a single unit, like this one. So instead of interconnecting three single phase, the most economical one to make a three-phase is actually to just make one core, and there will be three legs in which the windings are wound. Okay, so that comprises a three-phase already. So according to our annotations, there will be annotations regarding the what you call this construction of a three-phase as a single unit instead of using three single phase and interconnect it as it will become Y or delta for the connection. So actually we could make it as just a single what you call this single unit, okay, then just wound the winding in each of the legs. So this is a single unit, three-phase, cell type three-phase transformer. Okay, excuse me. Okay, let's bring out annotation number one. So instead of using three single phase to produce a three-phase, we will just construct one three-phase as a unit. And according to our annotations, used when big current or power is needed. Meaning the application of a three-phase, when big power is involved, okay, we are using three-phase. Right? Number two, more economical than three single-phase transformers. Like what I'm saying, instead of constructing three single-phase and interconnect it as is three-phase, it is more economical to build a single unit than building a 3 single phase transformer. Number 3, size is reduced and placed in a single tank. Okay? So, to produce a 3-phase, we just need one single tank, but of course it will be bigger, right? Okay? So, the size is reduced. If you try to use 3 single phase, you will be needing 3 tanks, right? 3 like this. But if you build a bigger one, of course a bigger tank, but the size will be bigger, and material wise, okay, you will be saving more on the material things. Number 4, needs less oil and fewer bushings. Of course, when the transformer is done, okay, you place it inside the casing, right? And for cooling purposes, you place what do you call this, an oil to cool off the windings, plus fewer bushings. What are bushings? Bushings are actually just the, considering single phase, there will be 2 bushings, right? Bushings is just actually the insulator, okay, between the terminal of the transformer, okay, with respect to the winding inside. So this is just an insulator thing. I think it's just a porcelain thing, right? So for 3-phase transformers, we need less oil because we are only having one tank. Of course, it's a bigger tank, but at least the oil that we will be placed inside will be less. Okay, fewer bushings. Okay, and number 5, occupies less floor space. Of course, what do you call this? If you make 3 single phase like this, and you place it in a certain floor area, the space occupied by the 3 single phase will be much bigger than the one which is 3 phase. That's the meaning of this number 5 annotation here. So this is just what they call this, storytelling regarding the what they call this, the reason why we construct or we build the 3-phase transformer. So when we say we use a 3-phase transformer, the power involved is big. It is more economical to build than a 3 single-phase transformers. The size is reduced, okay? And since the size is reduced, we will just be using one tank, so we need less oil and fewer bushings. And since we are only considering one object at a time, right, for constructing a 3-phase transformer, of course the space occupied by it will be less. Okay, let's try to bring out the transformer connections. The 3 famous connections for 3-phase transformers. There are 4 variations which are used. Okay, and I place the what you call this figure over here, from power plant to the household chores. If we produce an electricity, we need a power plant. Could be nuclear plant, hydro plant, okay, solar power plant. Like in the Philippines, we got the geothermal plant, right? We got the wind turbine. So in general, I just place power plant over here. If we try to deliver power to the households, okay, we need transmission lines, okay? We need secondary distribution lines. There is still the primary distribution lines. It's higher than the secondary, so I just simplify the figure. So from the transmission line, it go to the secondary line, okay? Then from the secondary line, it go to the household clients, right? So I will now try to specify the exact location of where these 3-phase transformers are located, okay? There are 3 variations of connection. Number 1 is delta-delta. Delta-delta. Delta-delta meaning the primary side is connected delta It is just like this. We bring out one terminal here, one terminal, then another terminal. So this will now be H1, H2, H3. But the configuration is delta. With respect to the secondary side, it is also delta. That's why it is termed to as delta delta. Okay, I will try to erase the leg so it will look good. So the first configuration is delta delta, and this delta delta connection, why we need to connect it in delta? The main reason behind is we use it for moderate voltages. Moderate voltages meaning maybe around 4,000 volts. 4,000 volts. Where in the system will be the voltage will be 4,000? It could be something here maybe on the primary post going to our houses, right? If there is a transformer here and it is a power transformer, okay, it could either be that the connection is delta delta or a Y delta. Because if we try to bring out the usage of a delta delta, delta delta is just for moderate voltages around 4,000 volts. It could be, we have here a transformer rated 4,000 volts primary. Okay, and the secondary is 120 volts secondary. Okay, on this portion, the transformer hanging on the poles going to our houses, right? It could be a three-phase transformer, right? In which the primary voltage is 4,000 and 120 volts. 4,000, that's why I place it there for delta delta moderate voltages, right? That's where this transformer is located on the electrical system. It is here. Okay. Number 2, for the delta to Y connection, the main purpose of delta to Y connection is for stepping up voltages. Meaning to say, if you got a 4,000 volts, okay, and you want to raise that up to 110,000 volts, you step up. Okay, so this is a step up connections. So the use of delta to Y is for stepping up voltages. So this should be the delta part is a low voltage. Okay, when it goes to the secondary, the connection will be delta. That's why it goes a step up. Okay, so this connection delta to Y, okay, is used for stepping up voltages. And where this transformer could be located on the electrical system for stepping up. It could be near the power plant. Because if we got it open in the power plant, okay, before we try to, they call this, deliver that voltage to the customers, okay, we must have to feed it to the transmission line. And to feed it to the transmission line, we need a transformer after the generator, right? And the, what they call this, the connection of the generator could be a delta to Y. So this number 2 connection in application, it's located near the power plant. Because you need to step up the voltage generated by the alternator, step up. It should be high. Why it should be high? If you feed it to the transmission line. If the distance between the power plant and the household is 500 miles, assuming it's 500 miles, okay, just make sure that the voltage starting here will be high. It could be 110,000 volts maybe. Why you need to be 100,000? So the current, what you call this, passing through the line here will be less. It's less. It's a high voltage, low current. So this 100,000, if it will travel 500 miles, okay, I think the 110,000, it could reach maybe when it reaches 500 miles, maybe it goes 105,000 maybe. Right? 105,000. Because if the voltage initially is low, after traveling for 500 miles, there might not be enough voltage, okay, needed by the distribution transformer just to energize our houses. So it's a must that the voltage generated by the generator will be stepped up before we feed it to the so-called transmission line. Okay? So the location of this delta to Y connection will be beside the power plant. There should be a power transformer over there with the connection, okay, inside. When it was constructed, a delta to Y connection, because a delta to Y is actually used for stepping up voltages. So the location of this delta to Y is beside the power plant, feeding the transmission line. Okay? Okay, I will try to erase this one. So it will look good. This one, I will erase this one. So at least we now know why initially near the power plant, before it is fed to the transmission line, the voltage is actually very high. It's just like in a water system, right? If you got a pipe, okay, and along the pipeline there are leakages, if the water flow coming initially from the deep well maybe is not so much, before it could reach the houses, no more water. Okay, no, the pressure is too low already to be given to houses. And electricity, it is the same. If the voltage is too low to reach the distribution transformer near the houses, okay, of course, the what they call this, the power that will go to our houses is not enough. Okay, instead of 120 maybe, it will go 90 volts. That's very bad. So it's a must that the initial voltage climbing this transmission line will be very high, and the transformer that is needed on that one is with the connection delta to Y. Okay? What's next? A YY connection, meaning the primary is Y connected, and the secondary is Y connected, and the application of this connection is actually for stepping up or stepping down. So this is a very good connection. So because it could be used for stepping up and for stepping down. So where could this YY connection be located? It's near the power plant. It is here. The YY connection. It is connected over here. Because a YY connection, okay, one application is for stepping up. To step up this 4,000 voltage output of the generator maybe to 110,000. Right? So we need the YY connection over here. YY. The first one is delta to Y, and the second one is YY. So if we try to look the location of this transformer here, okay, it could be located here. That is for stepping up the voltage generated by the alternator before feeding to the transmission line. And where is the other location of this YY? Because YY could still be used for stepping down, so it could be here maybe. Stepping down, right? So YY could still be located here on the poles near our houses, right? Because that 110,000, of course, the secondary of the distribution transformer here, it should be 120. So for it to become 120, we need a step-down transformer, and the connection should be YY. Right? So this YY connection could still be located near the power plant or near the distribution transformer going to our houses. Okay? Because we would like to reduce that 110,000 to a voltage of 120, maybe. Stepping down. Or what's the next one? The last connection is actually the Y delta. Y delta. Y delta is also for stepping down. So where could this be? Where could this connection be located? Maybe on the electrical system. It could be here. It's for stepping down. So it could be a connection Y delta. It could still could also be used for stepping down. So there are three types of transformers that will be located here. The YY connected, the delta to delta, and Y delta. And where's the other YY? YY for stepping down, it could be here. Could be here. Why we need it here? Supposing this is 110,000, upon reaching this one, this is 105,000. Okay, so there will be another transformer here that will step down this one to a safer voltage before we could deliver this one to the secondary transformers. So the other location of this YY will be maybe here to reduce this 105,000 to a certain voltage, maybe 13,000, right? And the input to the transformers over here will be 13,000, and since these transformers are stepped down, this 13,000 could be reduced to a voltage of already 120 or 230, right? So a big one, we step it down, again we step it down, okay, and the output will become 120 or 230 to be safe for us to use it. Okay, these are the, what they call this, location of the operation of transformers with regards to the connection. Delta delta, delta to Y, YY, and Y delta, it's all located here. Delta to Y and YY is near the power plant. The YY could be located on this portion of the electrical line for stepping down this 105,000 to a value of 13,000. So the voltage on this line here will be 13,000. So upon reaching this transformer, for us to get 120, we must have to what they call the step down this 13,000 to a safer voltage for us to use. It could either be 120 or 230. Okay guys, that's where what they call this, that's the location where these connections are actually used. For these windings, it is just what they call this, the shell type. To produce what they call this a three-phase, there will be three legs, right? So the first winding that will be one here is the primary, interconnect to connect two-phase windings. You get the center tap, you bring that one, that will be H1. Okay, another phase winding, we get the center tap. This one is connected with this, and the connection is here. We bring that one, that will be H3. And if we connect the end of this one with respect to the end of this one, okay, it is this, right? And we bring it out, and that will be H2. The connection for this is delta, right? That's the primary. That's why I didn't place it the secondary. For the secondary one, we place a winding over the primary, right? We place a winding over the primary. We place a winding over the primary. That's for the green one. Then we connect the end of this one with respect to the end of this one. We connect it. Okay, we connect the green one. And the center tap, we bring it out. That would be X2 maybe. We connect the end of this one with the end of this one. It is this. Considering the green marker, right? We get the center tap, right? We bring it out. That will be X3. We connect the end of this one to the end of this one. I will do it with the green one, right? It's this. Then I will bring that one. That will be X1. The connection is still delta. Okay? That's why I didn't place it yet, the green one. The first block is actually the primary winding, and the green one is actually the secondary winding. And if the connections are delta, just connect two windings, get the center tap, that will be first line. Connect two windings again, okay? take the center tap, that will be the next line coming out. The end of this one and the end of this one, we interconnect it, take the center tap, we bring it out, that will be the third line. 1, 2, 3, it's three phase. 1, 2, 3, it's three phase. Right? The first winding that was wound is actually the primary. The second winding that was wound is actually the secondary. And with regards to the connection, if it's delta, like I said, you interconnect right? You bring this one line, you bring this one, another line, you bring that one, another line number 1, line number 2, and line number 3. Same with the secondary. Okay? So at least we now know where the location of these connections are located in the electrical system. This is just a simplified view of this one. I just use one line here to designate the this leg here. Okay? The first thing that was found is the primary, the black one. The green one is the secondary. Then we bring out the terminals. So this one is just the simplified form of this one. Okay, that's it guys. At least we now know where these connections are located in the electrical system, okay? Delta, delta. Where's delta, delta? Located here for stepping down. Delta to Y is for stepping up. It should be located near the power plant. Okay? Before we will feed to the transmission line, we step up, right? So this delta to Y for stepping up is located here. For the YY, it is for stepping up and stepping down. So for stepping up, it could be located here. And for stepping down, it could be located here or here. Right? The last one is Y delta. It's also for stepping down. Stepping down, of course, this will be located near the post going to our house. Okay, that's it, guys. That's the 4 possible connections for connecting transformers and where they are located in the so-called electrical system. The next time around, I will try to bring out the other connections. Okay, good morning from Los Angeles. This is Professor David Jadrosria.